Before we start constructing our unit circle, I just wanted to share with you what some of its applications are. First of all, what the unit circle is it's a circle with the radius of 1 that is graphed in the Cartesian plane centered at 0, 0. That radius of 1 could be 1 unit of any sort, whether it's 1 centimeter or 1 mile. So this, in short, is a math tool that makes the use of angles and trigonometric functions easier. I call it like the foundation of trigonometry. Trig itself can show up in architecture, engineering, geography, astronomy, a ton of different fields. And you will get to see this a bit more as the chapter goes on, but trigonometry itself can be used to calculate distances that are difficult to measure by hand. So maybe we're talking about the heights of mountains, or maybe we're talking about how far away the stars in the sky are. Trigonometry can help us determine those things. And then here's where I get excited about it. Once you know the unit circle well and can use it in trigonometry, this allows us to be able to graph trig functions, sine, cosine, tangent, which can have us study waves of different sorts. I'm not just talking about ocean waves. I could be talking about sound waves or microwaves or the behavior of light. So kind of some cool stuff here. Remember, this would be graphed in the coordinate plane, so here's where the origin is. That would be 1 unit away, so 1, 0. 1 unit away, so 0, 1. 1 unit to the left, -1, 0. And 1 unit down, 0, -1. Now think of it this way. A full circle, a full 360 degrees is graphed in the coordinate plane. So where that 1, 0 is would be at 0 degrees, or you could also call that 360 if we think of a full revolution. Now, I don't encourage you to draw that little curly Q I just did in order to keep this nice and neat, but let's just go to the 4 order pairs we've done. From 0 to that y-axis would be 90 degrees. All over to the negative x-axis would be 180 degrees. Down to the negative y-axis would be 270 degrees. And then all the way back to our starting point, we could also call 360 degrees, which are called coterminal angles when they end at the same location. And in order to keep this nice and neat, I am still going to write some of that down and try to keep it nice and neat. All right, we will mostly focus on the first quadrant. So what you're about to see, please do not yet write on your own circle. I want to show you where this is coming from first. You'll physically see my hand when it's time for you to write. So let's start with our yellow angle. From the positive x-axis up is 30 degrees. Okay, so if this is a point on my unit circle, then that means the distance I'm about to show you in red here would be 1 unit. I'm going to drop a perpendicular from that point down to the nearest x-axis. This is not a perfect perpendicular, but you're getting the right idea. And now you can see that a right triangle is formed here. Okay. If this was 30 degrees, this one would be 60. And if it's a 30, 60, 90, I know the ratios. So we just said the hypotenuse is 1 unit. Think how ordered pairs are written. I'm giving it away. X, y. Okay, so we're going to try and figure out what this corresponding ordered pair should be. All right, hypotenuse is 1. To go from hypotenuse to short, you divide by 2. So my y value here would be 1/2. Okay, and then to go from short to long leg, we multiply by radical 3. Well, 1/2 times radical 3 is simply radical 3 over 2. So the x comma y would be radical 3 over 2 comma 1/2. All right, so I'm going to now show you how trig relates with all of this. If you think SOHCAHTOA, the little reminder for sine, cosine, tangent ratios, the sine of 30 degrees is opposite, aka 1/2, divided by the hypotenuse, aka 1. 1/2 divided by 1 is 1/2. Did you notice that 1/2 was the y value of our ordered pair? Okay, let's look at cosine of 30 degrees. Cosine is adjacent over hypotenuse. Adjacent to 30 degrees would be radical 3 over 2. Hypotenuse is 1. Anything divided by 1 is itself. Did you notice that that answer, radical 3 over 2, was what we wrote as the x value of that ordered pair? So in other words, what we're discovering here is that all of the ordered pairs on our unit circle, x comma y, will be written as cosine comma sine. In a moment, I'm going to show you exactly what you should write down to remember all of this. All right, so to remember this, make sure you're writing down that 30-degree reference angle. Remember, truly we formed a right triangle, but the ordered pair that was formed was radical 3 over 2, comma 1/2. Remember the radical 3 over 2, the x, really represented the cosine. So I would write this on the back of your unit circle. Ordered pairs on this unit circle, what we typically know as x comma y is going to be cosine comma sine. To be really redundant here, the cosine is the x, the sine is the y value of that ordered pair. This part I didn't have you discover, but for sake of time, I'm just going to give it to you because we have more coming still. Tangent is equal to sine divided by cosine. In terms of the unit circle, that's going to be y divided by x. All right, next, fold down the yellow flap. We're going to look at the next first quadrant angle, and you guessed it, if we're using our special right triangles to get exact answers, well, the next biggest angle after 30 would be 45 degrees. And so that means this guy from x-axis up is 45 degrees. As we know, the distance from the origin to any point on the outside of the circle is 1 unit. Let's go ahead and drop down our perpendicular to the nearest x-axis. Okay, if we use logic, 90 minus 45 gives me another 45. All right, if we know the hypotenuse is 1, let's find out what our corresponding x value would be and what our corresponding y value would be. And as we know, x is really going to be the cosine, y is really going to be the sine. Okay, well, in reference to our 45-degree angle, okay, 1 is the hypotenuse. I already said that, sorry. So I need to find the legs. To go from hypotenuse to leg, we divide by radical 2. And obviously we'd have to rationalize this. And so this would really become radical 2 over 2. So that's going to be the x value of this ordered pair. Y, you might have guessed it, is going to be the same thing, right? Hypotenuse divided by radical 2. Or you could just use logic. The legs are congruent, right? So this becomes radical 2 over 2 as well. And here's what you should actually write down on your unit circle itself. To keep things nice and neat, I wouldn't draw in all of the right triangles. All right, next reference angle is going to be a 60-degree angle. Fold down your green flap so you can see this nice. Don't yet write this down unless you write it separately. All right, so from x-axis up is 60 degrees. All right, from origin to point on the end of the circle is 1 unit. All right, drop down that point as a perpendicular to the nearest x-axis. We got a right triangle. Third angle, 30. All right, we know the hypotenuse. This is my short leg, which would be really the x value of my ordered pair, also known as the cosine. And the other guy is my long leg, which is the y value of my ordered pair, which is the sine. All right, if I know hypotenuse, to go from hypotenuse to short, I divide by 2. So x is going to be 1/2, or the cosine of 60 is 1/2. All right, long, well, I'll say this. To go from short to long, I multiply short, which I can't see very well, 1/2, there we go, by radical 3, and that's going to become radical 3 over 2. So the y value is radical 3 over 2, meaning the sine of 60 degrees is radical 3 over 2. All right, I'll show you what to write here shortly. So the good news is once you know the first quadrant, you can pretty much figure out the rest of the unit circle. And I will just mention, you can see my beautiful dog in the background, which is sweet. It was not on purpose. He just wanted to be around for the trigonometry, guys. All right, so since this isn't just a circle, it's a circle graphed in the coordinate plane, obviously this area was the first quadrant, and all of your ordered pairs are positive x, comma, positive y. So positive cosine, comma, positive sine. This area right here is the second quadrant. So all of your ordered pairs are going to be negative x, comma, positive y. This is the third quadrant. So all of these ordered pairs are going to be negative x, comma, negative y. And fourth quadrant, positive x, negative y. Reason I mention this is every flap we used in blue has a reference angle of 60 degrees. So here's what I mean. If I know this angle was 0 degrees or 360 degrees, right? I know the angle I'm going to do in red here. Okay, so from here to here is 180. Then the angle I'm about to do in blue, from here to here, I will tell you this. That angle is going to be 120 degrees. How do I know? Well, if I know that the rest of this blue flap is 60, I'm taking that whole red 180 minus the 60 to get the 120. All right, so reason I mention this is, I'm gonna erase some of this, give me a moment. Reason I'm mentioning via sky, there we go, now we can see what we wanna look at, is yes, this angle that you'll eventually write, wherever you wanna write it on your blue flap is 120, and reference angle is 60. Well, hey, if you look earlier, the ordered pair for the 60-degree angle was 1/2, comma, radical 3 over 2. This ordered pair is almost going to be the same thing. Oops, it's a 3, my goodness. Other than the fact that we said in the second quadrant, x is negative, or cosine is negative. So that's going to be negative 1/2 radical 3 over 2. Okay? The next green angle, I'm going to erase blue first. Here we go. Next green angle, really from here to here, would have a reference angle of 45 degrees. So if I take 180 minus 45, I'm going to be left with 135 degrees. So somewhere in there, I would write that that angle is 135. And since its reference angle is 45, I'm going to refer back to the 45 in the first quadrant. My ordered pair is radical 2 over 2, comma radical 2 over 2. Same thing here, except x is negative. All right, so in other words, we're applying shortcuts. Okay, the next angle, let me erase green here for a moment. I'm not going to be able to do yellow and you see it, so I'm going to do it in black. The next angle, from 0 to here, would end up being 150 degrees. Reason being is if this much I'm doing in a dashed is 30, reference angle, 180 minus 30 is 150. Okay. All right, so you're using the same ordered pair. We're just making sure that x is negative since we're in the second quadrant. All right, same idea applies elsewhere. So now I'm going to erase this. When I'm looking in the third quadrant, we already discussed both x and y are going to be negative. It's probably almost easier for you to do the ordered pairs first. So how about this? Yellow ordered pairs are always going to be some form of radical 3 over 2 and 1/2. In the third quadrant, both negative. Green ordered pair, always going to be radical 2 over 2, radical 2 over 2, both negative. And once again, I will write this cleaner when you actually see my hand in a bit. Blue is always 1/2, radical 3 over 2. It's just they're both negative. All right, the angles themselves, like so for instance, the yellow angle in the third quadrant would be 180 plus 30, so aka 210 degrees. The green one would be 180 plus 45, aka 225. The blue one would be 180 plus 60, aka 240. Okay, and so to finish us out, I will just write it in the clean form, but I'll just tell you the next angle, blue, will be 300. Next green angle will be 315. Next yellow angle will be 330. So I'll show you that one, 315. That one, 330. And then obviously 30 more degrees brings me back to 360. And the ordered pairs we already discussed. First quadrant applies, just make sure x is positive, y is negative. Okay, please pause this slide if you need to write any of this down still. Otherwise, I hope you enjoyed this video about the unit circle.